Alright guys, so now we are going to talk about the section 1.2 relations and functions. Let's first talk about interval notation, which is a way of expressing where a set of values starts and then stops. Interval notation, think about more than just one or two or three values, but a huge set of values. The best way to understand what is an interval notation, even though you have all the different case you might encounter and a different problem you will have to solve, let's try to solve the example number 1. In this example number 1, we are having x greater than 2. First of all, every time you're reading an inequality, you always start to read your inequality starting from the variable. In that case, x. So we're having right there x greater than 2. If I want to write the inequality in an interval notation, first of all, I'm going to represent my number line and plot my 0. Because x is greater than 2, it's a positive 2, I know on my number line 2, positive 2 is on the right. Then x is greater, so from 2, I need to go to the right, and I'm going obviously to the right up to plus infinity. And now I need to look at the symbol. There is no equal in my symbol, so I will use a parenthesis. So the interval notation will be written as a parenthesis right here and a parenthesis right there. Why do we have a parenthesis next to the 2? Because we said x is greater and not greater than equal, comma, and we're having a parenthesis to the plus infinity because we always have a parenthesis close to the plus infinity. Now let's jump to the example B. In this example, we are going to apply the same process, which is, first of all, I'm going to represent my number line. Second of all, I'm going to represent my 0. And because I know the number is 7, I will put my 7 to the right of this 0. It's a positive 7. Now, x is less than equal. Because it's less, I have to go to the right, to the left, and obviously I'm going to the left up to minus infinity, negative infinity. Let me erase this and go back to negative infinity. And so, the last point, because the last part, if I have an equal, I need to have a bracket, and my interval notation is going to be bracket. Obviously, I'm going to have 7, comma, negative infinity, and like positive infinity, I have always a parenthesis next to negative infinity. At last but not least, the last part, last example, on this example, which I think which are the easiest, I have already 3 and 8. I know 3 will be before my 8 on my number line, and now I know that all the solutions are in between 3 and 8. X is in between 3 and 8, and I will have a bracket for the 3 because I have an equal, and I will have a parenthesis for the 8 because I don't have an equal, and so my interval notation is going to be bracket 3, 8, parenthesis. Always you will always have on an interval notation the lowest number on the left and the highest number on the right. Lowest number on the left, highest number on the right. So now let's talk about relation and function. A relation is any set of ordered pairs, when a function is a relation in which every element of the first set corresponds to exactly one element in the second set. In other words, x cannot repeat. So when I look at the example number 2, and for a, well, is the relation a function, why or why not? Yes, it is. Yes, it is, based on the definition of a function. Now, B, is it a function or not? No, it's not a function. Based on the definition. This is the perfect example of if you know your definition, you can answer the questions. The example number 3 is about the use of a vertical line test, and this vertical line test will tell you if you have a function or not. If you have a function, the vertical line intersects a graph no more than one time. So when I look at the example number 3, I can tell that if I graph a vertical line, my graph is intersect only one time. So this is a function. This is why you have a function. Okay? When I look at the example number 3 for B, I represent my vertical line test, and I can see that I have 2 points of intersection, 1 and 2. And for this reason, this is not a function. Don't forget to write the definition of a domain with your book and the definition of the range of a relation. I will let you do the example number 4. Find the domain and range of the following relation. Okay? Now, let's jump on the example number 5. The example number 5, you have to find the value of f of 3, f of minus 4, and f of a plus 1. Let's do f of 3. Well, that's pretty simple. To find f of 3, basically you substitute x by 3 in your function. So f of 3 is going to be equal to 3 squared minus 6 times 3 plus 5. Okay, which is going to be 9 minus 18 plus 5, which is going to be minus 9 plus 5. So you get f of 3 equal negative 4. I like also, if f of 3 does bother you, you can write f of when x equals 3 equal negative 4. Now, f of negative 4, same idea, you are going to have negative 4, but this time because negative 4, I'm going to have that in between the parentheses, minus 6 times negative 4 plus 5, which brings me to 16, minus 6 times minus 4, minus 24, plus 5. Okay, and the answer is going to be 16 plus 5, 21, 21 minus 24, negative 3. F when x equal negative 4 equal negative 3. At last but not least, f a plus 1. So let me recall just a few seconds, x squared minus 6x plus 5. I'm going to substitute x by a plus 1. So I'm getting a f of a plus 1 equal a plus 1 squared minus 6 times a plus 1 plus 5. I would suggest that you need to know your perfect square. Like if you have a plus b squared, it's supposed to be a squared plus 2ab plus b squared. So in that case, I'm getting a plus 1 squared, so I'm getting a squared plus 2 times a by 1, which is 2a, plus 1 squared, minus 6a minus 6 plus 5. That gives me a squared. Then 2a minus 6a minus 4a. 1 minus 6 minus 5 plus 5. We're done. At the end of the day, maybe sometime you might find the answer as a factor a minus 4. Alright, so I think I'm done with this page number 4. Let's jump to the page number 3. I will let you do the example number 1 for x greater than 3, x less than or equal than minus 1, and x in between 4 and 7. Please rewrite the definition of a relations as well as the definition of a function, and you will define the if in the example number 2 if you have a function or not. Do you have a function For the A, well, if you graph your number line, your vertical line test, you know that you have 2 points of intersection, so this is not a function. When you look at B, you vertical line test, you got only 1 point of intersection right here. So yes, this is a function. I will let you answer the question C. Domain, let's talk about the domain right now. The value, the x value in the relation cannot divide by 0, cannot take the square root of a negative. Range is the y value. Basically, I like to resume that we are reading the range, the domain horizontally, when horizontally for the domain, and then we are reading the range vertically. Okay? So, if you have to define the domain in the example 4, you are going to say that the domain D is going to be 2, -12, 8. When the range is going to be 7, 3, and -16. Okay? Now, if I look at the domain for B, I'm going to say it's -2 and 2. When the range is going to be 0 and 4, apparently. Okay? Alright. Now, for C, I'll let you define right here the domain and the range by yourself. Don't forget to do these 3 examples about f of 2, f of -1, f of x plus 1, like I did previously. At least but at last, the practice problem. You know that you will have to do this practice problem home after the session we will have done in class. If you feel uncomfortable with the problem we are going to do in class regarding section 1.2. Thank you very much.